Hello everyone, welcome to the solution of LeetCode problem 18 named foursome. In this problem, we are given an integer array nums of n integers. Now, we have to return an array of all unique quadruples such that their summation is exactly equal to the given target. Now, we may return the answer in any order. Suppose in the first example, the array contains 6 elements, which is 1, 0, minus 1, 0, minus 2, and 2. Now here the target is 0. So here the 4 quadruples can be possible, where their summation of all of the elements will be equal to 0. One is this, minus 2, minus 1, 1, and 2. Another is this, minus 2, 0, 0, and 2. Another is this, minus 1, 0, 0, and 1. Now, in the second example, the array contains 5 elements, which is 2, 2, 2, 2, and 2. So here the target is 8. So here, one possible quadruple will be 2, 2, and 2 2s. So I hope you understood the examples. Now the constraint are, the array length can be in between 1 to 200. And each of the array element and the target can be in between minus 10 to the power 9 to positive 10 to the power 9. I hope you understood the constraint. Now let's move on to the algorithm. Now let's take this example. Now to solve this kind of problem, we will use the two pointers mechanism. So to apply the two pointer mechanism, we have to sort the given input at first. Then after that, we can able to apply the two pointers mechanism. So here, at first, the array can be given in any order. Then we have to apply the sorting operation. So here, after sorting, the array will look something like this. Now here, the target value is equal to 0 for this problem. So far, so good. Now, we have to find the quadruples such that a of I, a of j, a of k, and a of l, suppose their summation will be equal to the target. And we have to return all of the quadruples, but none of the quadruples cannot be duplicate. So this is the regular problem statement. Now, how can we solve this problem? By using the two pointers mechanism. Here, as we have to find the quadruples, so we have to take 4 pointers. Suppose the first pointer I is pointing to this first element. Now, I will propagate to all of the element from left to right. Now, what will be the next pointer j? The next pointer j is the right after I. So here, j is pointing to this element minus 1. Similarly, here we are using two loops. Similarly, j will be propagate to left to right. So far, so good. We have found I and j pointer, where I and j will move to left to right. Now, if we take minus 2 as the value of I and minus 1 as the value of j, so what will be the summation? Their summation will be minus 2 minus 1, which is minus 3. So here, if we take the value, let's consider it in general. Let's take the value a of I and a of j. Now, these two values are taken. So we have to find the value which is target minus a of I plus a of j. Because if suppose the target value is 4, now a of I is 2 and a of j is 1. So here we have taken 3 value and our target is 4. So we have to look after or seek the more 1 value. If we find another 1, so their summation will be 2 plus 1 is equal to 4. Or we can find another 0 because we have to find the quadruples. So here, now let's take another example. Suppose our target is 8 and a of I is 2 and a of j is 2. Now, if we find another 2 element which has the summation of 4, then our quadruple, their sum will become to target. So here, we have to find, if we take a of I and a of j in the consideration, then our target value t will be the given target minus a of I plus a of j. Or we can say that it is target minus a of I minus a of j. Now, so far so good. We have to find this value for each of the corresponding I and j. So how can we find it? So here, to find this value, we have to take another 2 pointers. Now, our next pointer, it is k pointer, which will stand the right before the j pointer, and our last pointer, L pointer, will mark the last element. So here, we have to take the value of a of k plus a of L. Now, if the a of k plus a of L is greater than this value t, that means we have to reduce some of the value. In those kind of cases, we have to shift the left pointer. So here, if this happen, it will be left minus minus. Now, if it is less than t, that means we have to increase some of the value so that their summation will become target minus a of I minus a of j. So here, we have to upgrade the k pointer. So here, k will be upgraded. So here, if any of the cases, this a of k plus a of t is equal to t, that means the summation of next 2 element is equal to the our targeted value t. So here we have find 1 quadruples. So in this case, we have to store a of I, a of j, a of k, and a of L into the output array. Now, it can be possible that a of I, a of j, a of k, and a of L has the duplicate value. So here, we have to take care of that. Now, after inserting the element into the resultant array, we have to remove or shift our pointer in such a position that no pointers is pointing to the duplicate element. Now, the overall time complexity of this algorithm is big O of n log n, where n is the length of the input array and log n is used for the sorting purpose. I hope you understood the algorithm. Now let's move on to the code. Now here in the code, we are given a function named forSum, which has a vector as a parameter and an integer value k. Now, if the size of the vector is less than 4, that means we have to return our empty list. Otherwise, we have to sort the given input. And for I pointers, we have to run a loop from 0 to n minus 1. Now, our new target will be the k minus a of I. If we take the first element, a of I. Now, for the element j, we have to run a loop from I plus 1 to n. So here, a of j will be taken as the second element. So here, new second target will be the new target minus a of j. Now we will take 2 pointers, left and right. Left is pointing to the j plus 1 and right is pointing to the n minus 1. Now here, left is less than right and inside this loop, our current sum will be the A of left plus A of right. And if our current sum is less than the new second target, that means we have to increase some of the value. That's why we have to upgrade the left pointer. And if our current sum is greater than the new second target, we have to degrade the right pointer. Otherwise, if the current sum is exactly equal to the new second target, we have to insert the corresponding quadruple into the answer. And we have to avoid duplication for the third element and the fourth element. So here, by using this, we will avoid duplication for the third element, and by using this, we will avoid duplication for the fourth element. Now, we have to again avoid duplication for the second element and the first element. And by using this loop, we will avoid duplication for the second element. And by using this loop, we will avoid duplication for the first element. After that, we have to return the result. I hope you understood the code. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.